ஸோ இது வந்து லாகின் இது பண்ணிடலாம், ஷேர் பண்ணிடலாம் யூடியூப் வீடியோலேருந்து ஷேர். ஸோ யூடியூப் சேனலுக்கு போயிட்டு அங்கேருந்து ஷேர் பண்ணலாம். Okay. So good evening. Welcome to this month's edition of Varahamihira Science Forum's monthly lectures. This is the 63rd lecture, as our friend Rajagopalan reminds us. We'd first like to thank Sastra Satsang Auditorium for giving us the facility. We thank you all for coming here. We thank Mr. Shridhar Ganapathy for accepting this at short notice. And thank you all for joining us live and for all the technical help at the staff at this auditorium. I'll give a brief introduction about VSF and this talk, and then we'll start with no further ado. Varahamihira Science Forum was started about 5 years back to bring lectures on science and technology to the general public, not just to specific targeted audience. We've had monthly lectures for several months now, several years now. This is our 63rd, as Ari just said. And we've just had a couple of interruptions because of illness, one corona, and so on. The point of the lectures, point of this monthly meeting is to connect the general audience who's interested in science and technology, not just the core audience in that field. And we've had a wide variety of speakers, both amateur and professional. Today we have a professional geologist who is going to talk about how geology applies to the temples. The vast majority of Indian historical monuments are temples, Jain, Buddhist, Hindu, stupas, and so on. They are surviving ones are mostly made out of rock. They are of different varieties of rock all over the country. And so from a geologist perspective, he's going to give us a lecture. Shridhar Ganapathy is a geologist. He's a professional geologist. We've shared his resume in, not to stress too much on his resume because we are short on time. I'm going to give a very brief introduction. He recently came with us, our THT group, for a tour of the Hoysala monuments around Mysore and Hassan. And before that, he gave an excellent lecture on how the different stones like granite and schist and sandstone affect the engineering and the ability to intricately carve all the sculptures on the monuments. So we requested him to give a talk to Varahamihira Science Forum about it, and he agreed at short notice. And so we are very delighted to have him. We've had geology is not a subject that's usually treated in science and technology lectures. We've had 2 or 3 lectures on geology. We had Pranay Lal talk about the Thar Desert. Long before that, we had Dr. Singananjam talk about cruising coastlines and wandering rivers, how the rivers and their movement shape the ecology and the geology of the city and the geography of how the society developed later. So without much further ado, I request Dr. Shridhar Ganapathy to give us this talk. Thank you, sir.
Thank you very much. It's indeed a pleasure for me to share my knowledge with this august audience. And let me not take much time in normal introductions. Let's get into the subject straight. Before the whole thing, I like to thank a few people around. Mr. Sundaraman, who happens to be a computer aided engineer, doing working here at Ford, and he had a lively discussion with me regarding the rock mechanics. And then members of Tamil Heritage Trust, some of the PowerPoint presentation, PPT presentation of PK Srinivasan and Mr. Shiv Shankar Babu really gave me a different perspective to think. And Mr. Gopu Rangaratnam, he has always been there for the last 3-4 years, edging me to talk something on the geological aspect of temple architecture. And a couple of weeks back, I had been with the group Tamil Heritage Trust, and it was a wonderful experience for me. And a lot of insight into the geological aspect also came into. And last but not the least, Professor Swaminathan, he has always been an inspiration for me. Yeah. And it's, of course, it's all books. And let me go with the whole package will be this: what are rocks, what are minerals, how did they evolve. This is a to small introduction to geology, and later on we can straightway get into the architecture of Hoysalas, which we visited recently. Next. Among the greatest creation of human beings are the monuments created by them. First, it's for the dwelling, for his own shelter, and then a space for his worship. Maybe it's a temple, church, or mosque, and then the sculptures, and also to satisfy the innate aesthetics urge. And last but not the least, for protection, because all over India you can find a number of forts, starting from Kashmir to Kanyakumari. You have, particularly in the northern region, where they face external forces. There are many forts, starting from Rajasthan and other places. So it's the greatest creation of human beings is the monuments that he has created. Let let us see what is earth science. Earth science is a study of physical and chemical processes that shape the earth, including atmosphere, ocean, and landforms. Interdisciplinary field in geology. Geology is not something like a pure science like chemistry or physics. It deals with chemistry. When it deals with chemistry, it's geochemistry, geophysics, geomathematics, oceanography, and meteorology and astronomy. It's an interdisciplinary subject, and its subfields. When as a student, one has to go through subjects like petrology. Petrology is a study of rocks, structural geology like plate tectonics, earth movements, faults, poles. These are what we study in structural geology. Mineralogy is the basic thing. Minerals is what makes the rock. And then the paleontology is the study of fossils. So some connection with the biology also occurs here. And then then its application, whenever it comes to application, is the natural hazards like earthquakes. Now recently we have seen some of the earthquakes, and a lot of work has been done, and a lot of work has to be done also. Volcanic eruptions, tsunamis also is a phenomena which we have seen at the recent past. Extraction of natural resources, that is one of the important material, important subject that we deal, the application, climatology and atmospheric science. All these things, we have gone much forward. Every area has got its own specialization, which is connected to geology, but a lot has to be done also. Remote sensing, that's one area fast expanding. It applies to agriculture, mineral exploitation, defense strategy, etc. Now, Now, just let's get into what is geology and what are the different types of rocks: igneous, sedimentary, and metamorphic. I don't want to go deep into it. Most of the people may be knowing what it is. And It's also divided as intrusive, extrusive, clastic, chemical, biological, foliated, non-foliated. Let's get a little deeper in the next slide also. So it's igneous rock, the classification of igneous rocks. At this particular point, I like to see that greens clipping, the molten material, which we call it as magma, that emanates from mantle layer. We know the earth is made of crustal layer, the top layer, and then you have the mantle and then the core. So it is at the mantle, at the higher level of the mantle is where the the magmatic material, which is in a semi-solid condition under high temperature and pressure, exists. And when this starts coming to the upper area, we call it as effusive rock, extrusive rock. And let's see, since I said it is a subject which deals with physics, chemistry, biology, a basic thing is what when a material is formed at a lower level, deep inside, the rate of cooling happens to be much uniform. The crystallization takes place much better, and you get coarse grain on the lower, deep inside. When the same material starts coming, there is a rapid cooling of the magmatic material, and you find fine grained crystals, or even sometimes a glassy layer too. So deep inside, we call this kind of a material as granite and gabbro. When it comes to the upper surface, we call them as rhyolite and basalt. Don't bother about the nomenclatures. It's not to be bothered if you understand the basic principle. Deep inside, when the crystallization takes at a uniform way, it becomes a coarse grained material. The same thing when it comes to the upper surface, it becomes a fine grained material. That's all. And the granite and gabbro, why we call this is granite has got higher amount of silica and it's lighter in color. We have some few samples which I have kept it there. At the end of the session, probably if time permits, we can even have a small discussion. And next one. So here I have given the rocks and its cooling history. When at the top layer you find granite, which is coarse grain on the left hand side, which is coarse grain. The same material, when it comes down, it becomes a fine grained rhyolite. On the other side, on the right hand side, you have the mafic material. The reception seems to be, I mean, the color is a little different. It's dark in color, less siliceous with high gravity, specific gravity, whereas on the other side, granite, it is of a low specific gravity. And gabbro and basalt are seen. Sedimentary rocks, it's how it is formed. The huge material like rocks, hillocks, rocks, boulders, and fine material. It reaches to sand and silt and clay. So when these fragmentary materials are there, it starts sedimenting and we find the sedimentation process. And the sedimented process, after completion of the sedimentary process, it gets compacted. And the level of compaction also makes a difference in the sedimentary rock. Some of them, for example, I happen to see at Kailasanada temple at Kanchipuram. This happens to be a material which is not so compact, even by nibbling, you can take it out. The same material, when it is at Badami, it's compacted, well compacted, it's harder. So there are many aspects of it. And it's something like, I'm to tell you as sort of a metaphor, it's something like our Lonavala Chiki. You have grains and it's filled with the interspaces are filled by jaggery. Same kind of a thing happens. You have grains and these grains are totally covered by materials like calcium carbonate or siliceous material. So that's how a sedimentary rock formation takes place. Yes, next one. And here you can see sand grains loosely packed, and the other one sand grains compact. Whereas sand, since material gets layered, you get the layering structure, which you can see it on the central downside. On the other side, you have the conglomerates, where the fragments happens to be bigger and compacted, and that's what we call it as conglomerate. Even in English, we say conglomeration. It's a combination of different material of different sizes. And the last one is Kanji Kailasana temple. This is made out of sandstone material. So just to see the layering is very clearly seen in sandstone. The other one is a shale, which is very, very fine grained. And this, when it is subjected to certain temperature pressure condition, it can turn out to be a metamorphic rock also. Limestone is a calcium carbonate formation. It can be organic as well as chemical formation. Due to the chemical precipitation, you get calcium carbonate deposits. Sometimes by the accumulation of the biological materials, also you get the limestone. Dolomite is calcium carbonate, magnesium carbonate. Metamorphics, basically, the existing sedimentary rock or metamorphic a sedimentary rock or an igneous rock, even for that matter, a metamorphic rock, when it is subjected to pressure of temperature or a chemical environment, it changes its equilibrium. The mineralogical equilibrium changes, it gets disturbed, and it tries to attain a stable equilibrium at a later stage. And in the process, you get some minerals developed. And it's not only that, the pressure could be direct pressure, uniform pressure, or otherwise a directed pressure. During the directed pressure, certain minerals gets aligned as well as it's layered, and you get bands. And some of the gneissic rock, which you find, for example, in Mahabalipuram, you find some of the gneissic rocks, hard material, and if you closely see, some of the minerals gets aligned. And we call it as granites because it's a common terminology which we use it. Something like your Xerox. Xerox is not actually a Xerox, it's a photocopying, but it's a company's name. But even today, whenever we want to take a photocopying, we always say Xerox. That's the kind of a thing that we use as a granite terminology. You have a huge area, huge materials encompassing this granite terminology in today's world. So next. It's a beautiful formation. You can see the sandstones, particularly when the grains of silica. When it is subjected to temperature and pressure condition, it becomes quartzite. Very, very hard material. And other one, the limestone. In Tamil, we call it a sunambu. And the same sunambu para, when it gets metamorphosed, you get marble. I kept a sample for that also. And here, on the other side, you can see the shale, which I was talking about it, as sedimentary rock, which under a progressive metamorphism, that means temperature, pressure, and chemical environment, it gets transformed into slate, phyllite, schist, and gneiss. And that's how it happens. Today, we will be talking something about the schist rock of the Hoysalas. Hoysala, when I talk about it, it's on the southern Karnataka, Belur, Halibedu, and those areas, Somanathpura, these places where this material is much more available, schist. We call it as a schist for, so it has got certain physical phenomena, which we will be talking about it very soon. Yeah. And the other one, so no, other one is migmatite. Tanjavur Perikovil, or what we call it as a big temple, Brihadishwara temple. Usually, people call it as a granite temple. Yes, it's a granite temple from a common point of view, but it's a migmatite. It's a combination of your metamorphism and the metamorphism and what you call it as the granitization. The granite rocks, when it is subjected to metamorphism, you get this kind of a migmatites. You can see wavy layers. It's a sort of a fluid material getting injected into it, and you get this kind of a material. If you go to any granite shop, you can see such kind of a thing. It's what we call it as migmatites, and in a common parlance, it's also called as a granite. Now, you will get surprised to say one person says that red color material is granite, other one says black color material is granite. So, in a common terminology, as I said, most of the igneous rocks, some of the metamorphic rocks are all termed as granites. And it is not only now, even at a much before, maybe even 1,000 years back, they didn't call it as a granite. Probably they would have said as hard rocks, soft rocks, and medium hard rocks. So that is how they have classified the rocks during those times. Yeah. So again, the commercial granite, there are many things. Some of the characteristic features are it has got a large presence of silica, which is resistant, and maybe the weathering will be much minimum. And we will see a few slides at a later stage. And it is can be easily quarried. You can see on this side uh, what they call it as a mural joints. It is easy for the quarrymen to remove this material. Is something like taking out the cake because of the joints that you find there. Joints are nothing but a weaker plane that is developed in the rock, and it's much easier for you to remove it. And uh, it is also can be easily polishable because it's harder. A hard material can be easily polished when it is a soft material. For example, a limestone cannot be polished, whereas granite can be polished because it's hard. It takes up that polish. And it's all resistant to fire and porosity, and it's normally free from fractures. So these are all some of the characteristic features which helps to use this material as a building material. And it's also the minds of the craftsmen during those days. What could have been the thing? If at all we look back, probably they would have classified them as hard rocks, soft rocks, and medium hard rocks. Then the sizing is one important thing. If you have a huge log of wood, then it cannot be used as a furniture in your room. You need to cut it to a proper size. That's what we call it as a sizing. And this is quite comfortable in granites rather than other material. So sizing, you can see on the lower side, or dressing. Whatever we need, that's the size we need. That's the dimension we need. And that is possible in granites. Okay. Next. Now, other thing which need to be seen is what are the blemishes? We call it as a blemishes because it doesn't work for us, but it's a natural process. It's highly fractured rock. I happen to see this one in Ellora caves, in one of the remote Ellora caves. Because of the fracture, today it is seen in a dilapidated condition. The same thing if secondary minerals, when the rock gets solidified and then at a later stage, secondary mineral starts filling up in the gaps. These are not totally fused, so it is prone to weathering, and that's what you see in the central side. The total face is defaced, and you can see in a small area also the pores are very clearly seen because the materials have been removed. And here also a Ellora kind of a thing in cave number 32, if I'm not mistaken, the secondary mineral gets filled up and everything is lost. That's one of the reasons why, if you see, it's all plastered so that the blemishes can be covered up to a certain extent. Okay. So I don't want to take here much. It's a common sense that land forms over the ages, cities, civilization, rivers, and ports. If at all, if you try to see the history of it, like Kurukshetra, Ayodhya, Gaya, Patliputra, any kind of a thing, it's all dotted around rivers. And geology plays an important role. That's what I just want to tell you. Yes. Next one is the physiography of India. You have what broadly classified as Peninsular India, the lower peninsular region, extra peninsular India, which is Himalayas, and Indo-Gangetic Brahmaputra plain. the Indo-Gangetic Brahmaputra plain happens to be more fertile, and you can see a lot of kingdoms, lot of emperors, lot of dynasties have flourished in this area because it's a fertile land. And whereas the peninsula, most of the places, at least the northern part of the peninsula, is of Deccan traps, Deccan volcanic material, what we call it as basalt, and it gives you high relief, high mountains, etc. So it's not so easy for anyone to penetrate. Maybe that's one reason why the foreign invasion was minimum on the southern side. Then let me just give a simple example of confrontation of Badami Chalukyas and Harshavardhana. Harshavardhana, he was there around the 6th, 7th century, a great emperor, and he ruled the whole place of Indo-Gangetic plain, almost going up to Afghanistan. And when he tried to made an attempt to get inside the southern side, that is the Deccan area, it was not an easy cakewalk for him, and he was defeated also by a king Pulikesi II of Chalukya time. And Pulikesi was no match to him as far as military might is concerned during that particular time. But the territory which he was holding was advantageous to him. So it was not easy for him, for the great Harshavardhana to invade so comfortably. He was trapped. In fact, he retreated. And the same thing holds good for Marathas and Mughals. Maratha chieftain Shivaji had a handful of people. When I say handful, of around 2,000, 3,000 was his army. Whereas Mughals, you know, the mighty Mughals. But still, it was not possible for the Aurangzeb to totally sway the Deccan area. At least till his life, Shivaji was always a sort of an irritant, and he was not able to subjugate. So that's what I said, the landform which forms makes a big difference in history. Let me rivers. Now let us come close to our place of Hoysala. When you talk about the rivers, Pandyas, Cholas, Chalukyas, Rashtrakutas, Eastern Chalukyas, Hoysalas in particular, all started their origins somewhere closer to the river banks. And it's seen here, Pandyas in Vaigai and Solargar at Kaveri River Basin and so on. It's satellite imagery where the Hoysalas has taken origin somewhere at a place, a small place called Angadi, red color mark which has been made. And Belur, which is the capital, was just hardly around 120 kilometers. And the port, Belur was very close to that. And Belur was around roughly 120 kilometers from the ports of Arabia Sea. And Sharavana Belgola was, which is very close to Belur, not very far away. It was flourishing religious prominence, with a religious prominence in the 7th century itself. And by the time the Hoysalas came to the good level, to the manageable level, around 12th century, it was a great thing. And this is just to say that rivers, towns, etc., had its own connotation with the rocks. Yes, we have landed at land of Hoysalas. Hoysalas. Audible? Yeah. So the first one is the Belur. Second one, the lower bottom, is on the right hand side is Halibedu, and you find a few things. A very characteristic feature is that the temple which you see, it's put on a raised platform. Please look at it, and we will discuss much more about it. On the other side here, Halibedo, you get a very beautiful structure, which we call it a stellate structure. And the top layer, you have two temples, one on each side, and it's connected by a passage. So let's talk something later at a later stage about the stellate structure and the Bhadra structure. This is just to give you an impression of what this area comes out. Now, let's get into the physical and engineering properties of it. I don't want to discuss everything. The important aspect is this chlorite schist is a soft rock whose hardness in most scale falls around 2 to 3, a scale which goes from talc first to diamond, which is 10. The second one is that its strength, the mechanical strength of this material, is poor compared to granites, what we have been discussing for some time. And this strength of this rock schist, what we call it as a chlorite schist, it ranges from 250 to 1000 kilograms per centimeter square. That's the strength. Whereas when you talk about the granites, particularly the gneiss and other things, it's 2,500 kilograms or more than that per centimeter square. So that's a kind of a difference you have between the hard rock and the soft rock. Yes. Yeah. You can see the central figure. A gentleman is using a sledgehammer to break open the granite material, to size it. He needs a sledgehammer. Whereas here, a picture taken recently, somewhere a person was working. I mean, the video is there. It's not working, but I will try to show it at the later stage if it is possible. This is, they have used the carpentry tool, what we call it as chisel. In Tamil, we call it as uli. And the material with which as a hammer that he is using is a wooden plank, a small wooden base. So that is the amount of force that he has to put to shape this material, whereas the rock, which is granite, needs a sledgehammer. That's what I just want to tell you here. Granite's common terminology, I had discussed enough. Most of the terminology, most of the granites which we call as granite encompasses a number of materials from the igneous and some rocks from the metamorphic rock also. A small thing, how hard it can be. This one strip taken from the Tanjavur Kovil, where it is, the inscription is Raja Raja, and it is very quite fresh. And after 1200 years or so, still it is. That's because the material, the granite, is quite hard. The same thing may not happen with basalts, which we saw some time back in the slides. Okay. Yeah. Here, the top layer is the famous our Marmalay. The second one is Ellora. The third one is our Hoysala. In fact, if you will see a small pen is also inserted. First two are bas reliefs. When I say bas relief, it's on a wall. The relief is just two-dimensional and a little more. It is not a full relief idol. So in this, the first one, you can see the size of the sculpture is usually a little large compared to the Ellora one. That's also a bas relief, but its size is less because it's much more softer than the granite. much more. I mean, to a greater extent, it's not as soft as a schist rock which we see in Hoysala. The third one, it's an intricate one. It's a three-dimensional structure. I mean, the sculpted all three direction, high relief material, but it looks like a beautiful miniature. It's not a bas relief at all. So much of intricacy can be used in the soft rock. That's what I want to say. So to tell you what is hardness, just let's take the graph. And the most scale of hardness, as I told you, is starts from tal first to diamond 10. That's what is there on the graph line. On the other side, you have no scale of hardness, which is more of quantitative one. This one is more of a field test and field test also. It's not only field, but field test also, whereas the node's hardness is determined quantitatively, whereas this one is more using certain knife, pen knife, your nail, iron knife, such a kind of a thing. So most scale of hardness is an approximation, more useful during field, whereas this one is a quantitative treatment. And both are compared in that graph very clearly. You can see the actual variations. For example, just to tell you, like diamond is around 7,000 on no scale, whereas the second one, which is around from diamond to the corundum, which is 9 on the lower side, it's roughly 2,000 in a no scale. It's also tabulated here. So there is a lot of variation, and hence the Mohs scale of hardness cannot be taken just as a qualitative term. It's a field test. Now, let's get into a little bit of engineering aspect of it. The compressive strength or crushing strength, also it is called. The compressive strength of the rock is a maximum pressure that a rock can withstand before it fails or breaks under compression. If a certain amount of load is given, we have uniaxial, triaxial tests, etc. But let's take it as a uniaxial test. When the loading takes place at one stage, it fails, it cracks, and that is what we call it as a compressive strength. The crushing, this can be expressed mathematically as C0 equal to P by A, where C0 happens to be the compressive strength, which is given in the form of a kilograms per centimeter square, whereas P, the load at failure in kilogram, and A is the area of cross section of the stone in centimeter. Just to see, I mean, instead of getting into that, there are three factors. One is the C0 is the compressive strength. For a given rock, it is more or less constant. Whereas when you talk about the P and A, they are variables. Now, as the area increases, P should also increase to have a constant C0. This is the principle that we use in Hoysalas. We expand, and the area wise, it's increased to maintain the structure. Let's get into the next one. Here also, we have been talking about compressive strength or the crushing strength of rocks, particularly the igneous rocks, sedimentary rocks, and metamorphic rocks. In general, I can say igneous rocks and some of the metamorphic rocks has got compressive strength high, but not all metamorphic rocks have the high strength. Whereas sedimentary rocks usually is little low, and schist, chloride schist, or some kind of a shale has got a very low strength. That's all. Now, to quantify them generally, to put it in a nutshell, instead of beating around the bush, granite and quartzite, the first one and two, their compressive strength happens to be kilogram, 2,500 kilograms per centimeter square, very high. When I talk about the shale and schist, which is on the lower bed, 5 and 6, it's 250 to 1,000 kilograms. And there is a variations in these areas, 1,000 to 2,500, 500 to 2,500. It's all because of the different changes that happens in these rocks. A sandstone can be loosely packed or compacted, and gneiss can have layers, shales, have porosity. That gives you a range of values in a given limit. All these are low, whereas granites and quartzite has got a high compressive strength of 2,500 kilograms per centimeter square. Yeah. Now you can see two beautiful temples. One is Hoysala's Belur temple, and the other one is Bagadishwara temple of Tanjavur. And here one is touching the sky, other one is short and flat. What it means is that the compressive strength here is low. So instead of extending upward, they have extended on the horizontal side. That is, the area has been increased instead of going upward. That's like that. So that's since the compressive strength is less in the case of fluorite schist of Hoysalas in general, the temple structure is laterally placed with minimum of high-rise structure to decrease the load and thereby increasing the stability of the total structure. That's the essence of this slide. Now the transverse strength is basically, it's nothing but a block is kept and you have two supporting points, and on the top the force F is applied. Now you will see at one stage, when the force is applied at one stage, it can yield, it can fail. And look at it in a different way. If these supporting points, if it is close by, instead of this L, it's L minus X. In that case, it will survive. This is one reason why in Hoysalas we find many beams. Since it is a weaker rock, many beams are short length. Yes. Yeah, next one. Yeah. That's a beautiful description. There is a slight bend on the specimen, and you can see here also, if the same supporting point, pin, if it is brought closer, probably it can take more force. That's exactly is the principle that is involved in this. If you can see, the adjacent pillars are much closer. Whereas when you talk about the Vijayanagara kingdoms, where they use granites or Tanjavur, Solargar, Samrajatil, you found most of them are slim, slender, tall, because it's mechanical strength. The compressive strength happens to be higher, whereas in this case, the compressive strength is lesser, and the flexural strength, not compressive strength, the flexural strength, the bending strength is less. So we use beams at close quarter, and the pillars are also kept close to each other so that it can hold some more weight. That's it. Some architectural features of Hoysalas like multi-shrine, stellate, Badra. So we'll be just talking about this one. Yes. We give a number of things. Kuta is nothing but a dwelling place. Ekakuta, Divikuta, Trikuta, Chatushkuta, Panchakuta, Saptakuta, Navakuta. It's like different multiple shrine is what we have it in this place. Whereas in the southern side, particularly in Tamil Nadu, we don't find this kind of architecture. It's just because we have granites, whereas they have chlorite schist, and it has got a weaker the rock is weak mechanically, so they need to adapt themselves to a different situation. That's why what they do is, instead of having many shrines everywhere, they make it something like a shrines at different places, like 2, 3, 4, and it is all connected on the horizontal level. So all these shrines are connected with a common hall known as Rangamandapa, and that's the reason why we do it. Here you can see Panchalingeshwara Govindahalli under Mandya district. You can see the top shrine 1, 2, 3, 4, 5. All 5 are put together in a line, and you have a common veranda kind of a thing here. It's a plan, and it is here. The same way in the Hoysala Land, Lakshmi Narayana temple, a Trikuta. Trikuta means 3 shrines are put together at different horizontal levels. It is not one above the other, etc. Stellate and Bhadra structure of Hoysalas. Stellate is what we call it as the star-shaped material, how it is formed, etc. If you see, you have a beautiful drone picture of the top. Here also, same of the Halibedu. If you see on the right-hand side, you have 2 shrines, and it's well ornated. I mean, it looks star-like, the first one. The same thing, it's on the other side, in this side, on the left-hand side. So I have tried to show from different angles. And this star-like structure is what we call it a stellate. And when it is connected to give an additional support, we call this as a Bhadra structure. Let's get a little deeper into it. Now, in this case, a Bhadra structure is formed by the extension of a square. You can see a yellow square, and it's extended further on all 4 sides. So normally in this Hoysala temple, you have on the extended side, you have certain kuta, or what they call it as a shrine, and it's all connected by a common area. On the other side, you have what we call it as a stellate, a simple stellate structure. You can have a complicated stars also. Let me make it simple by saying that simple stellate structure is formed by superimposing 2 similar squares rotated at 45 degrees angle on a fixed central axis of square. Like one square is there already, and then the second square is slightly turned, rotated by 45 degrees, and what you get is a star-like structure which is seen on the other side. So this is what I showed you in that drone picture. It's a beautiful video. Unfortunately, we can't see the video. But one thing I can show you, one is a straight line, a straight wall. The other one is a zigzag wall. The zigzag, the straight wall, when the force is applied, it goes flat in a simple way. The other one is a zigzag one. When the force is applied, maybe a simple one, a force is applied, it still holds down. So that is what is used in your stellate and in your Bhadra structure. Can you go one step before? It's possible? Yeah. Here, if you see the stellate structure, it's the borders, the corners are irregular. Same way here also in the Bhadra structure, you can see it's all in an irregular form. It's not straight walls, it's cut at 90 degrees. So this gives you an additional support for the structure to hold on. So here it's a simple thing where my grandson's material, I just used it, but it was really wonderful to show the thing. Maybe if we get it, we can show the thing. In summary, if you see, chloride schist as a primary building material might seem counterintuitive. It is of a great disadvantage. That's what people will say. Given its lower compressive strength and fractional strength, the unique architecture structure, stellate and Bhadra, employed by the Hoysala architects, along with the short and stout pillars, had helped to compensate for the material's weaker properties. Comparatively, the use of granite by Cholas dynasty provided greater structural strength, allowing for construction of taller and more slender pillars with longer span between them. My respectful salute when I saw this, their workmanship, their ideas, I was astounded. It was such a nice thing. Probably just as a tourist, we go and have a look at it and come back. But when we look at their engineering marvel, they might have not known about composite strength and other things, the formulas, but by their experience, they know much more better than the present day engineers, structural engineers. So that's exactly just this is a summation of what has been seen. There is a slight change in the uh, small error in the meter, centimeter square, etc. Let's take stellate. Spelling is also wrong. Stellate and Badda structure. The square side is 100 meters. In that case, the area of cross section is of the square or the Badda structure, initial square happens to be 10,000 square meters. Let's take it that way. So the increase in area is there, which can be calculated, and let's not spend. That is an easy way of calculation. So increase in area of a stellate structure and Badda structure happens to be around 17.15 and 48% for this measurement. And then when we talk about the increase in the number of walls, because these walls, if it is a straight wall, it can easily fall. Whereas when it is a zigzag wall, it can hold on. So the wall which is just 4 walls for a square, here from the 4 walls, it becomes 16 walls. Whereas on the other side, for Badra structure, if you work out, it will be 4 from 4 to 20. So we are increasing the wall numbers. And then when you talk about the decrease, I mean, as far as a straight wall, suppose if I have 10-meter wall, if there is a tsunami, definitely it can fall. Or maybe it's easy for if it's a thing. Whereas if you have a zigzag wall, it can withhold. So that's the thing what I like to say. So ultimately, we could observe the following changes for stellate and Badda structure, assuming the initial base area as 10,000 square meter or centimeter, whichever we take it. So area gets increased, interlocking points. When I have number of things, walls like this, the interlocking points increases and the span decreases. These are the ultimate thing which you get it from this engineering aspect of it. And they have mastered it. And it's said that they had around 2,000 temples all around in this short span of 200 years or so. Now what is available is around 200, 300 temples right now. But every temple they have introduced this phenomena. Maybe someone with a good brain, a group of people might have utilized this kind of an idea into it. Yeah. So, so it's a unique picture which I was talking about, the same thing. Yeah. Next one. Here is a beautiful thing which you need to see. See the lower platform. They call it as Upapida in our terminology. And further is Adhisthana. And after that is only the entrance. I don't have a pattern. You have an arrow, just see that is the entrance. So it has been raised. The material, the base level has been raised to that extent. So the upper high rise structure is minimum so that the temper can be saved. Whereas the top layer, in the initial stages, they have gone still more higher, but it has been dismantled because it happens to be a weaker rock and it has fallen. So they have removed it, I think. This is what has been uh, told, or we were able to see it in our literature. So you can see at every point, you have a pillar to support it, and the basal level is also raised. So short length walls, locking points are more, the pillars are there to stabilize, and increase in the height of basal structure increases the visibility of the temple. This is what this picture really gives you. Oh, again. It's again my grandson's thing. And some or other, I don't know. He made me a structural engineer by his enthusiasm. I think I can see a symmetry is there. Here you see, you have different types of Dravida, Kadamba style and everything. But one thing is very clear, there is a horizontal symmetry as well as vertical symmetry. Here also, this is a Chalukya Dravida 724 points stellate. Everywhere, that symmetry is maintained from top to bottom, which means the loading becomes uniform. If it is imbalanced, then there is always a problem of uh, getting into problems. Yeah, this is to tell. I was always talking about it. This is seen in a temple. Is Mr. Manoj Gundana? He has pointed out this one. It's not that suddenly we have found that these people have done it. They have a stellate structure in the temple, and this is a multi-stellate structure. The star structure is seen by rotating in the square. This means they know much more better than us. We have been back reading it, trying to find out from after they have done it, we are trying to see the science behind it, but they have done the science much long, and this is a proof of it, what it is. Yeah. Yeah. This is a very interesting thing. A dilapidated structure near Koravangala. It's a place. Uh, we are so fortunate. Our group is such that they do a lot of experimentation, and we all went there, and we could see this is a pillar with a cavity, and in some places you have a protrusions also, and it's a small kind of pillar, 3 feet or so. So 2 3 feet is makes up to 6 feet or 7 feet of that pillar, and how they couple it. That's the beauty of it. And this is all in a dilapidated area, which we happen to see. All of us, or some of us, TST people were there with us. It was a very interesting experience for me. Next one. This is how they would have used this for their lathing. I mean, the pillars might have been during those days there was no lathe. That's what people say, but there is a definite proof to say that if they don't have this kind of a C type lathes, etc., of the today's time, definitely there is a possibility that they understood the concept of lathe work. So this is what I have just made a photo picture. Probably this could have been one way by which they might have gone. You need to have a heavy, probably lead, uh, uh, maybe a heavy masonry structure, so that there is no wobbling when there is lathe work goes. And with a simple structure, they can rotate it manually because it's just 3 feet. And you can see at the top there is a cup like thing, and here also is a thing. And now I will show you something there. Can you see this is one top, you have a cavity, the other one is that's a partition, and this all we have seen it, and that shows how they would have coupled this rock. Whereas in our place Tanjavur, you have a huge pillar of 15 18 feet, or in Vijayanagara, Hampi side also, because the material is granite, whereas here it is chloride schist. Yeah. And there was one more thing interesting. One of my friend at Koravangla only, I happened to see a Nandi which can be rotated. And after looking at the Nandi, which is rotated, I thought of this idea. And it's not something innovative idea. It's just 1 + 1 is 2. That's all. So in short, Hoysala used chloride schist, which is of a low strength rock, to its maximum best by increasing the area of cross section, be it stellate or Badra. The process they had reduced the length. In the process, they had reduced the length of the wall to a minimum with more locking points. These locking points are further reinforced by pillars for additional stability of the overall structure. Because it's like a definition I need to put it, so I am reading it verbatim. It is to be pointed that granite monuments like the Brihadishwara temple has no compulsion to increase the area by way of stellate or Buddha structure because of its inherent strength. And if at all they increase the area, it is further to reinforce the stability of the overall monument, thus giving a proverbial rock solid stability. The base plan of these high strength granites are usually square or rectangular, where the number of walls are less and individual length of the walls are more compared to the Hoysalas. Let me tell you, even in Brihadishwara temple, you have a little small Bhadra structure. They talk about it slightly. Certain structure goes up and down. If at all, some of my friends who have seen Tanjavur can see it. It's not flat, straight wall. Slightly it goes up and certain a wall goes a little down. And it has been explained by one Dr. Shankar Naran once long back. But this is well practiced by these Hoysalas. That's what I want to say. It is obvious that the chloride schist will break on its own weight if it is mined as a lengthier slab and as the bending strength is extremely low. Hence, I feel Hoysala has used stellate and Buddha's design in their monuments more for stability and in the process used judiciously the softness of the material for its intricacy, which happens to be their specialty, where they had excelled than their predecessors Cholas. Yeah, with that, probably I think it's. I will close my thing, and if at all someone has got something, would definitely I can answer whatever I know a little bit of it. Let me tell you again. I thank Tamil Heritage Trust members for opening my eyes. That's something really great. And in the last 4 or 5 years, out of which, as I said, 2 years have gone for a toss, but that association has given me a different input altogether. Thanks a lot. Thank you very much. Yeah, there are some rocks, if it is time permits. You can have a look at it because next session is about to start, I believe.
No, we have 20 minutes or so.
Yeah, yeah.
So you can go to the podium. If anybody has a question, you can come and ask here.
No problem. Let's.
Oh, so the assumption is that by trial and error, they have arrived at the length of the pillars and the rocks.
Yes, definitely. I mean, as I look back,
Hmm.
experience is the mother
Mother.
of invention, and I'm sure about it. When first time when they see certain thing, it doesn't work. It falls. So we need to do alterations, and at one stage they become perfect master of what they do.
Great. Thank you. Thank you for
Myself, Chandrasekharan.
Yeah.
Thank you for the wonderful presentation. I have been always wondering when I visit the temples, what is the binding material between the blocks that is holding the big structures?
Usually,
I see white, some paste like structure.
usually, as far as I know, like granitic structures, I was talking about sizing. If there is a perfect sizing, one above the other, it can be put, and like brick placing. That is, it's not that one above the other in such a way that is an interlocking system. So that's one thing. In certain areas, some places they might have used the sudai kind of a material. I don't know, but most of the heavy structures, I think it can stand on its own. Mr. Uh, uh, Gopu sir also can give some kind of an input because my
Particularly
exposure,
in
let me tell you, my
ceiling.
exposure to tempo is very, very meager. And whatever I found, a few like Tanjavur and Mamalai and maybe Ellora. That's all some of my thing. This Hoysala was my recent exploration. But I have seen it that most of the huge material has put one above the other, and it's put in a brick-like construction so that the holding capacity and the gravity takes care of it.
Thank you.
Yeah, in most monuments there is no interlocking material. In fact, that is there from even the Harappan days. There is no binding material. There is no interlocking material. It is from Harappan civilization to ancient monuments to Nalanda, Buddhist brick monuments to a lot of granite monuments. In a lot of structure, there is no interlocking mechanism. But in some places there are. So it's not like it's doesn't exist at all. Basically, just gravity is what's holding to just structurally properly arranged. The measurements are all well. Distance is maintained by trial and error. They figured out how to build these things so that no binding material is needed, which will not heat and compress in cold and hot weather. And just by understanding of how much weight it can support, they have constructed it. That's why these things last over 1,000 years, right? They'll continue to last several thousand years. Same things what the Egyptians or the Mayans and the Aztecs have done with their pyramids. No binding material in most places, no interlocking connections. Which one? Chisel, hammer and chisel. Very slow, laborious, extraordinarily, you know, um, painstaking work. Yeah, they need not just the sculptor to do use hammer and chisel, but they need iron specialists to keep the chisels in condition. Keep them sharp and all that stuff. There are names.
May I add? You visit the YouTube lecture of last week's Dr. Dayalan Tamil Heritage Center, where there is a
So, for the question on how chiseling was done, one suggestion is Dr. Dayalan's lecture last week on Tamil Heritage Trust. I'm saying this on mic so it will go on the YouTube video. So Dr. Dayalan spoke at Tamil Heritage Trust last week. Go to Tamil Heritage Trust YouTube channel. You can see the recording. So any more questions? We have some on. Go ahead.
Thanks for the wonderful lecture, sir. Actually, I just wanted to know whether the rocks in Ramar Setu Bridge or the mountains in Ramar Setu Adams Bridge, tested by Geological Survey of India, or any other important things are noted in the specific structures of them.
I didn't get your point exactly.
Now, I am talking about the rocks of Ramar Setu Bridge.
Ramasetu.
Ah.
Well, I have no much of an idea here, and it's a controversial subject, and I don't want to give my comments on that.
Okay. We have some questions on YouTube, so let me pass them on to you. One question is there a problem that there can be a shortage of rocks in the future, or are there unlimited number of rocks? Are we overusing them? Will we run out of rocks?
Well, the process of rock formation takes lakhs of years and millions of years, and the sediments that gets inside, you have a converging point and emerging point. That's what the plate tectonics talks about it. So there will be definitely a recycling of this material in a different form, like where there is an emergence, the material starts coming, the volcanic material starts coming, and rock gets solidified. So it's going to be a continuous process. Of course, the destruction of rock material at high level, it's definitely going to spoil the aesthetics of the land surface. That much I can say.
Okay. The second question that was basically already asked about slicing of rocks and cutting cakes like squares, seamless rock, and so on. Third question is can we say these stones might become exotic rare pieces or collectors items? You have brought a
Yeah,
collection,
yeah.
so
I have collection. It doesn't. But one thing, the fossils that we have, antiquity, to know our antiquity. Unfortunately, these are all scooped out, and it's very difficult to go back to the history of the organic evolution. Otherwise, I doubt whether it will be in short supply.
so another question is the Kailasanatha temple you showed some sandstone. How long will it last? Will it disappear in 500 years? Will it all become completely eroded? How
Every
long?
possibility is there, definitely, because the material is loosely packed. And even today, if you just number, I mean, the nails, it starts coming out. And if it is not properly protected, it's not properly conserved, probably by 500 years, in 200, 300 years, itself, it may get spoiled. Because it's apart from the natural devastation, natural phenomena, it's the human intervention also plays a dominant role in most of our temples.
Um, so Gokula Krishnan asks, what are your views on the National Geo Heritage Bill?
It's wonderful. I mean, the government is taking some initiative in this direction, and probably it may be definitely useful for us to see our heritage is preserved. For example, in most of the Western countries, if a monument is seen 200 or 300 years old, they call it as a monument. Whereas we, even a next door temple happens to be about 500, 600 years old, and we don't bother about it. So, this kind of initiative taken by heritage will definitely help us in maintaining our heritage.
Very good. Any other questions? If not, we are active on. I asked that. So repeat over. So so the debate or conversation did not stop here at this forum at this auditorium. We are on WhatsApp, we are on Facebook. Our WhatsApp groups are very active, though they are not always active about the lectures that we give. Uh, so you can join our WhatsApp group. You can contact any of the organizers. You can see our Facebook, Twitter, Instagram. Contact us. Uh, Shridhar Ganapathy sir is there in our group. We can come to the physical medium, the meetings, and interact with our people. The point of having this Varamira Science Forum is also to have a forum where people get to meet each other and talk about other issues, or bring these, build a community of people with like-minded interests. So it's not just a particular lecture, but other topics before, after, and all that. So thank you, Sridhar sir, for an excellent lecture. We are
Thank
glad
you.
that you came with us and gave us such a wonderful insights into this geology of rock monuments. I would like to invite Sri Mohan, our organizer, to give you a small token of our affection and appreciation for this presentation. Ange, camera ಅಲ್ಲ ಇருக்கு. So small token. Thank you very, very much. Uh, so if you have any closing comments, go ahead. Otherwise,
I'm really thrilled to it's my exploration in the initial stage, and I need to thank TSG and is the great stage Professor Swaminathan, because he's a man without talking, he inspires people. He is a great teacher, and I have seen 5, 6 years back Mr. Gopu, Shivshankar Babu, RK, all those people. I mean, today their standing is very different in the society from the point of knowing the heritage. I'm sure about it. And it has inspired me, in spite of the fact I'm a little elderly, touching 70. Thank you very much.
Uh, Thank you, Sridhar. Lot of technical details for the experts, and also very at an overview level, the lay audience also got to know a lot of things. So it was a treat both for the common audience as well as for the technically inclined. Thank you so much. I think a lot of preparation has gone into this lecture. We thank you so much, and thanks to all the audience here who have come here to this hall today. Despite so many events happening in the city, it's we are really thankful to you for having taken the time and being present here physically. And thanks to all the audience who are watching it live on YouTube now, and also to those who will watch it later to understand and appreciate this specific talk about geology and the aspects of the geological aspects in temple construction. Thank you all, and we will uh, announce the next lecture. Most likely, it is going to be in the fourth Saturday of March. That's our usual slot, the 4 p.m. on the fourth Saturday. That has been our slot for these monthly lectures. We will announce the topic and the speaker in our social media handles, our WhatsApp groups, and also Facebook and all the mediums. Thank you all, and thanks to the Shastra Satsang uh, organizer, for giving us this hall. Thanks, Karthik, for the technical support. Thank you all, and hope to see you all in the next edition of our series. Thank you so much.